Assalamu alaikum. Today we are going to correct together the exercises of chapter 13, the alkanes. Please, before starting, bring your chemistry book, your answers on these exercises, and a pencil to correct it. First of all, we will start by the exercise number 6. In this exercise, we ask you to find the isomers of C7H16. When we want to give or to write the isomers of a compound, we will start always by writing the linear chain alkane, which means without branches. So, since we have here 7 carbon, the linear chain must contain 7 carbon which are related together by a single covalent bonds. Don't write now the hydrogen that surround each carbon to facilitate your work. So since this chain contains 7 carbons, so it represents the heptane. Each structural formula we have lateral carbon, which are the carbons at extremity, and we have the carbons between these two lateral carbons, which represents the central carbons. To find the other isomers, we must take off at each time the carbon, the lateral carbon, and put it as branch and connect it to one of the central carbon. So if we take now one lateral carbon, we obtain a main chain with 6 carbon atom, and the carbon which is taken off must be attached to one of these central carbon. Let's start by the first possibility. We will attach the carbon. We number the chain in the two direction. We must attach the carbon to the central carbon, which hold the number 2. In this case, we have a branch with 1 carbon, so it represents the methyl group, and we have a main chain with 6 carbon atoms, so this isomer represents the 2-methyl hexane. We have another possibility if we put the carbon taking off and we attach it to this carbon which hold the number 3, and if we attach it to this carbon, we have also a carbon which is attached to a central atom that hold number 3, since we must start by this direction to give the ramification the smallest number. So in these two cases, we have the 3-methyl hexane. So these are the two isomers that can be obtained when taking off one carbon from the linear chain alkane. In the remaining steps, we will work on these two isomers obtained when taking off one carbon by taking in each step one lateral carbon. So when working on this isomer, we cannot take off this carbon since it's attached to a carbon that hold before already holding a branch. When taking off this carbon, the branch remains to 6 carbon atom. It contains 6 carbon atoms, so we cannot take a lateral carbon which is attached to a carbon that hold before or already holding a branch. So we must take the lateral carbon here, and we obtain a main chain made up of 5 carbon atom and the branches before still in this place. But this carbon which is taken off must be attached or can be attached to this carbon or to this one, or when attached it to this one, to this carbon, we obtain an isomer with 2 branches, 2-methyl group, and we have the 2,3-dimethyl pentane. We can attach now the carbon to this central carbon, and we obtain in this case the 2,4-dimethyl pentane. We can attach it also to the carbon that already hold this carbon, and we obtain in this case the 2,2-dimethyl pentane. When working on this isomer, we can take or this lateral carbon or this one, but in the two cases, if we put the carbon and attach it to this carbon, we obtain the 2,3-dimethylpentane, which is obtained before. And if you put it here, we also obtain the 2,3-dimethylpentane. So we are obliged to attach it to the carbon number 3, and we obtain in this case the 3,3-dimethylpentane. The carbon taken also from this main chain can be also attached to the branch, and we obtain one alkyl group, which is the ethyl group, and we obtain the isomer with main chain with 5 carbon atoms. In this case, we obtain the 2 or the 3 ethyl pentane. So these are the isomers with the main chain with 5 carbon atoms. For the isomers with main chain, which is made up of 4 carbon atom, let us start by this carbon, this isomer. In this isomer, we cannot take this carbon since it's attached to a carbon that which hold a carbon or a branch. We must take this lateral carbon, and we obtain a main chain with 4 carbon atoms and with these 2 branches as here. So the carbon which is taken off can be attached or on this carbon or to this carbon. In the 2 cases, we obtain the 2 for this alkyl group, 3 trimethylpentane. When working on this isomer, we cannot take this carbon and this carbon since they are attached to a carbon with a branch, and if we take off this carbon, we obtain also the same isomer. Also for this one, if we take this carbon and we attached it to the carbon here, we obtained also the same isomer, and also for this one. So these are the 9 isomers for C7H16. At the end, we must complete each formula by the hydrogen atoms, and we must respect the rule of valency. The valency of carbon is 4, so it can undergoes or it can be involved in 4 single covalent bond. So here it made 1 covalent bond with carbon, still have 3 covalent bond which with the hydrogen. Here we have 2 single covalent bond. The carbon still have to made 2 single covalent bond with hydrogen, so we add 2 hydrogen. The same for this carbon. If we look to this carbon, we have here 3 single covalent bonds, so still have 1 covalent bond with hydrogen. For this one, the carbon makes 4 covalent bond with each carbon, so it doesn't need another or hydrogen. So we don't have here a bond between carbon and hydrogen. For exercise number 7. In this exercise, we have to give the name according to IUPAC for these isomers. First step, we must determine or identify the main chain, the chain that contains the biggest number of carbon. This one is the main chain. It contains 5 carbon atoms, and this one is the branch. It represents the ethyl group since it contains 2 carbon. So, and this alkyl group is connected to the carbon number 3, so we have the 3 ethyl pentane. The second one is the methane, since it contains only 1 carbon, and we have 2 bromine which are attached to the carbon, so we have the 2 dibromomethane, and we don't have to specify the number or where the brom is attached, since we have only just 1 carbon. The third one is the 2 chloropropane. We have a 3 carbon atom here. The fourth one is the 2-bromobutane. We have 4 carbon in the main chain, and bromo is the branch which is attached to the carbon number 2. This one we must determine the longest chain. If we consider this chain here, we have 8 carbon atoms, and we have 1, 2, 3, 4, 5 branches. If we take this chain, we have here also 8 carbon atoms, but we have 1, 2, and 3 ramification. This one is considered as one ramification, the isopropyl group. So, since the first one contains the greatest number of ramification, we must work on this one. When we have 2 chain and 4 of the same number of carbon in the chain, we must choose the chain that holds the biggest number or the greatest number of ramification, which is this one. In this case, we start by this extremity, since when starting here, the branches take the smallest number. If we start by this extremity, the first branches is attached to the carbon number 5, while here the first ramification or branch is attached to the carbon number 2. So we must start by this direction, and we have 1, 2, 3, 2, 2, 3 methyl, and we have 3 and 5 dimethyl. Since ethyl, the letter E comes before letter M in the alphabetical order, we must name the ethyl group before, and we have 3, 5 diethyl, and we have 2, 2, 3, each number for one branch of methyl, trimethyl octane, and we have comma between the numbers and a hyphen between the number and the word. For this one, the longest chain is this one with 1, 2, 3, 4, 5, 6, 7 carbon atom. We have 3 branches, 2 methyl and 1 ethyl. We start by this extremity, since this ramification take the smallest number, and we have 3 methyl, and we have 4 ethyl. We start by ethyl, 4 ethyl, 3 dimethyl heptane. For this one, the main chain is this one or this one, since it contains the same number of carbon, and we have this branch ethyl, this one chloro, this one bromo, and we have methyl. We start by bromo, since letter B, and letter C for chloro, letter E for ethane, and letter M for methyl. So we have the 2 bromo, 4 chloro, 4 ethyl, and 3 methyl hexane. For exercise number 8, we must correct, we have some mistakes in the representation of this molecule. We must correct these errors here. The errors is made on the are related to the valency of carbon. Here the valency of carbon is 4, and this carbon makes 4 single covalent bonds, 1 with the carbon and 3 with hydrogen, so it verifies its octet. This one has 2 single covalent bonds with 2 carbon, and it has also 3 covalent bonds with hydrogen, so it doesn't verify its octet. We must take 1 hydrogen. We have now 2 with carbon and 2 with hydrogen, which is correct. And for this carbon, we have 3 covalent bond with 3 carbon, so it needs 1 with hydrogen. This carbon verifies its octet, and the same for this one. When working here, we need 2 here, and we don't need here 2, but we need here 2 for carbon to verify its octet rule. For exercise number 9, we must represent each of these organic compounds. When representing an organic compound, we must start by the main chain. Here the pentane, so we represent 5 carbon with single covalent bond between them, and don't represent the hydrogen, let them for the end. We must put the alkyl group starting by ethyl and methyl. Ethyl contains 2 carbon, and methyl contains just 1 carbon. The ethyl is attached to carbon number 3 and the methyl is attached to carbon number 2. So here we have just carbon and here we have 2 carbons, and now we complete the formula by adding the hydrogen atoms for each carbon to verify its octet rule. For the second one, we have 2,2,3,4 tetramethyl for 1 propyl octane. We start by the octane by writing 8 carbon in the main chain. For tetramethyl, we have 4 methyl group, 2 methyl group on carbon 2, 1 on carbon 3, and 1 on carbon 5. For 1 propyl group contains 3 carbon in its formula. Why we write here 1 to indicate that the first carbon in the propyl group is attached to the main chain. So the first carbon is attached to main chain, and we complete by writing the hydrogen atoms. For the 3,3-dimethylhexane, the hexane, and we have 2 ethyl group on carbon 3 and on carbon 3. Each one contains 2 carbon atom, and we complete with hydrogen. For exercise number 10, here we must also write the formula of the alkyl halide, methane, so the carbon number 1, just 1 carbon in the formula, and 1 iodine. The remaining bond are made between carbon and hydrogen, so we need 3 hydrogen for the carbon to verify its octet. 3 chlorohexane, the hexane here 6 carbon, and we have the chlorine atom on carbon 3, and we complete with hydrogen. For 1 bromo, the same, we have butane, 4 carbon of butane, of 4 carbon atoms in the butane molecule, and we have 1 bromo here in carbon 1, and in carbon 2 we have 2 chlorine. And thanks for watching.